Greetings and welcome to my new calculus channel. My name is John Gabriel. So, the only vacuous retort ever against a new calculus is that it doesn't treat inflection points correctly. Well, it's not only vacuous, it's absolutely false because the new calculus treats inflection points correctly and mainstream calculus does not. Okay, so why do the apes of the Church of Mainstream Academia make that claim? Simply because in the new calculus, we have the following. So we require that for a derivative to exist, there must be a tangent line. Okay, so if we have f of x is equal to f of x plus n minus f of x minus m over m plus n. So if we have a curve like this, this is the cubic and there is an inflection point here. By the way, there is no tangent line here, even though mainstream idiots think there is, because a tangent line may never cross at the point of tangency. However, there are half tangents. So for example, on this side you have a half tangent, and on this side you have a half tangent. Now in the new calculus, if the only m-n pair that satisfies, let's just do this, q of x m n. So q of x n x m n is always 0, and it's called the auxiliary equation. Okay, it's always 0 and it's called the auxiliary equation. So if the only m and n, the only m and n that make it 0 is 0, 0, 0, then that means there's an inflection point here. Okay, and it's consistent wherever you are in the new calculus. If you have another curve, something like the one that you see here, the red curve, which also goes through this 0.11, it has a vertical tangent there, right? Well, according to mainstream, it does, and according to the new calculus, it does not. It just has half tangents, so you only have half tangents here. Okay, but here again, the only pair which would satisfy the auxiliary equation is 0, 0. Okay, so it works perfectly. And of course, if mainstream morons get withdrawal symptoms from not having any other pair excepting 0, 0 there, they can still pretend there is a derivative there, because 0, 0 always satisfies q of x m n if there's an inflection point. Now, what's interesting is that despite all the hatred and the ignorant criticism that was leveled, especially by academics such as Jack Hazinger, an ex-Harvard alumnus, the mean value theorem, which is the fundamental theorem of calculus, doesn't care about inflection points. Okay, so look, if I place these points right on each other, the mean value theorem still works. Okay, so we look at these integrals here, this one and this one. Let's just do that. Okay. So if we move those points, that one and that one, excuse me, then you can see that the mean value theorem doesn't care about inflection points. So whether there's a derivative there or not is, quite frankly, immaterial. Now, why do you have this supposed inconsistency? Well, that's because of the flawed formulation of mainstream calculus and the wrong ideas that were inherited from Newton and Leibniz. Okay, so nothing you can do about that. If you're not already a subscriber, become one and tell your friends about it and click like. Also follow me on academia.edu. I will place a link to an interesting article explaining why the mean value theorem is the fundamental theorem of calculus. My name is John Gabriel. This is a new calculus channel. Till next time, goodbye.